Welcome to Your Math Explained, where we make math simple and clear. My name's Angela, and in this video, we're going to tackle 4 transformation problems, each one a little bit more involved than the previous. We'll look at vertical and horizontal shifts, stretches, reflections, and even how to transform coordinates and full equations using formulaic and replacement techniques. If you need a refresher on either one of those techniques, be sure to check out the intro videos for combined transformations. But if you're ready to move beyond the basics, then follow me and let's dive into those intermediate problems. So let's start with this function here. We have f of x is equal to the square root of x. And we're asked to sketch this new transformed graph. So notice how this transformed graph is already in the form of y is equal to a times f of b times x minus p plus q. So because it's already in that form, we can just go ahead and write down what the transformations are. So our a is equal to -2, which means we're going to have a vertical expansion by a factor of 2. But because the 2 is negative, there's also going to be a reflection over the x-axis. So we also need to reflect over x-axis. Next, our b here is actually 1, which means that there is no horizontal expansion and compression. And our p here is 3, which means that we're going to translate 3 units to the right. And lastly, our q here is 1, so that means we're going to translate this 1 unit up. So these are all the transformations that we're performing here. So what we're going to do is we're going to take the points that are on this original graph. So we're taking the point 0, 0, 1, 1, and 4, 2, and we're going to be applying those transformations to each of those points. So let's start with 0, 0. If we perform a vertical expansion by 2 and then reflect over the x-axis, that is still going to be 0, 0. Next, we're going to translate 3 units right and 1 unit up, which means we're going to end up at 3, 1. The next point is 1, 1. If we expand this vertically by a factor of 2, we're going to get 1, 2. But then we're going to reflect over the x-axis, which means that the y value is going to change signs. So that means we're going to end up at 1, -2. And then when we perform our translations, we're going to end up at 4, -1. And now the last point, we start at 4, 2. A vertical expansion by 2 is going to give us 4, 4. And then reflecting over the x-axis will get us 4, -4. And then the translation is going to get us to 7, -3. So now those are going to be the new locations of those 3 points. So let's go ahead and plot them on the graph. So we have 3, 1, which is here. We have 4, -1. And then we have 7, -3, which is here. So that means our new graph is going to look like this. So for this next problem, we're given that y is equal to some function f of x. We're not given what the function is, but what we do know is that the point 4, 2 lies on the graph of this original function. The question is, what would its new location be on this transformed graph? So in order to find its new location, we need to determine what kind of transformations have occurred. So since this is already given to us in function notation, it would be easier for us to use the formulaic method. So let's go ahead and write that down first. So we would have y is equal to a times f of b times x minus p plus q. So notice that there's one step we need to perform in order to get it into that form, and that is we need to factor out the coefficient in front of x. So we're going to get y is equal to -3 times f of, we're going to pull the 2 out in front, and then we're going to get x minus 3 in brackets, and then we have our plus 5. So this means we now have our values for a, b, p, and q. So let's go ahead and write down what the transformations are. So our a is -3, which means we have a vertical expansion by a factor of 3, along with a reflection over the x-axis. Our b here is equal to 2, which means we have a horizontal compression by a factor of 2. And then finally, our p is 3 and our q is 5, which means we're going to translate 3 units to the right and 5 units up. So now that we have what the transformations are, we can go ahead and take our point 4, 2 and perform those transformations on it. So that means we're going to start with 4, 2. A vertical expansion by 3 is going to make it 4, 6, but then reflecting over the x-axis is going to result in 4, -6. A horizontal compression by a factor of 2 is going to get us 2, -6. And then a translation, 3 units right and 5 up, is going to get us to 5, -1. So that is where the point 4, 2 is going to end up at. Now for this next problem, we're given that g of x is equal to the absolute value of x. And we're asked to sketch the graph of this equation here. So notice that this is a little bit different from the previous 2 questions because we're not given this equation in function notation. So that means what we want to do first is rewrite this in function notation so that we can identify our a, b, p, and q. So in order to do that, let's take a look at what our function is. So our function is the absolute value of x, meaning with x being our input, the input goes inside the absolute value signs. So if we look at our transformed equation, this is our input. That is going in between the absolute value signs. And then this 1/2 is outside. So therefore, this tells us that this is y is equal to, we have the 1/2 on the outside, and then we have g of, and our input is -x plus 4. So now let's go ahead and factor the negative sign in front of the x. So then we get 1/2 times g of negative, and then we will have x minus 4. And now we can go ahead and write down our transformations. So our a here is 1/2, which means we have a vertical compression by a factor of 2. And then our b here is -1, which means we don't have any horizontal compression or expansion, but we do have a reflection over the y-axis. So reflect over y-axis. And then our p here is equal to 4, which means that we're going to translate 4 units to the right. And since our q is 0, there is no vertical translation. So now we're going to apply these transformations to the points on this original graph. And for this one, you don't actually need to do all the points, but notice that it's actually a straight line. So it's a V shape, which means we can actually just perform the transformations on these 3 points, and then we can connect them. We're going to have, this is 0, 0. This is -3, 3. And this is +3, 3. So first we have -3, 3. A vertical compression by a factor of 2 is going to give us -3, 3/2. A reflection over the y-axis means that our x value is going to change signs, so that's going to be 3, 3/2. And then translating 4 units to the right means we're going to end up at 7, 3/2. Next, we're going to take our 0, 0, perform the same transformations. So we get vertical compression, that stays at 0, 0. Reflection over the y-axis, that's still 0, 0. And then finally, the translation is going to get us to 4, 0. And then our last point is 3, 3. So a vertical compression is going to give us 3, 3/2. A reflection over the y-axis will give us -3, 3/2. And then a translation 4 units to the right is going to give us 1, 3/2. Okay, so let's go ahead and plot those points. So the first one is 7, 3/2. So that is going to be right here. And then we have 4, 0, which is right here. And then we have 1, 3/2, which is right here. Okay, so now let's go ahead and connect those points. And that is what our transformed graph is going to look like. So notice how the reflection over the y-axis doesn't actually change anything, right? Because the left side and the right side of this graph, they're already mirror images of each other. So if you took this original graph here and you flipped it over the y-axis, it's actually going to look the same. So which is why when you look at this transformed graph, it looks like it's just a vertical compression by a factor of 2 and then a translation 4 units to the right. Okay, and now we come to the last question of this video. So for this question, we're given the equation of a circle. So notice that this is not a function. And we want to determine the resulting equation if we apply the following transformations. First of all, because it's not a function, and if you look at the transformations that we're performing here, it is not in that prescribed order. So it's not in the order where you have to perform your expansions, compressions, and reflections before your translations. So this tells us that for this problem, we should tackle it using the replacement method. So first, we're going to translate this 2 units right and 1 unit up. So translating 2 units to the right means that x is going to get replaced by x minus 2. And then translating it 1 unit up means that y is going to get replaced by y minus 1. So remember, for replacement, everything is the opposite, meaning going to the right or going up means it's negative, and then going down and going to the left is positive. And now for the next transformation, we're going to stretch it horizontally by a factor of 2 and stretch it vertically by a factor of 1/2. So stretching it horizontally by a factor of 2 means that x is going to get replaced by 1/2 x. And stretching it vertically by a factor of 1/2 means that y is going to get replaced by 2y. Again, notice how everything here is the opposite. So let's go ahead and actually do these replacements in the original equation. So we start with x squared plus y squared is equal to 4. And then if we put in our replacements, we're going to get x minus 2 squared plus y minus 1 squared is equal to 4. So this is our first replacement. Our next replacement is to replace x with 1/2 x, which means we're going to get 1/2 x minus 2 squared plus, and then y is going to get replaced by 2y, so that'll be 2y minus 1 squared is equal to 4. So this is what the resulting equation is going to be. In fact, let's go ahead and actually draw what this new graph looks like. So we can go ahead and take our original points, 0, -2, 2, 0, 0, 2, and -2, 0. So we're going to take, let's say, our -2, 0 first. We're going to translate it 2 units to the right and 1 unit up. So that's going to be 0, 1. And then we're going to perform our stretches, and it's going to end up at 0, 1/2. Our second point is 0, 2. Perform our translations, and we're going to get 2, 3. Perform our stretches, and we get 4, 3/2. Our next point is 2, 0. Performing the translations first, we'll shift it to 4, 1, and then the stretches will shift the point to 8, 1/2. And then the last point is 0, -2. Performing the translations first will get us 2, -1, and then performing the stretches will give us 4, -1/2. So let's go ahead and plot those points. So we have 0, 1/2, which is here. And then we have 4, 3/2, which is up here. Just going to cheat a little bit and put it on the points. It'll look something like that. So a quick recap of what we went through in this video. We went through function and coordinate transformations, as well as full equation replacements. We also learned how to graph relations like circles, which are not functions, using transformation rules, and how to do all of this without relying on a graphing calculator. And now it is your turn to give this a try. So given that we have our function f of x is equal to the square root of x, can you identify what transformations have happened if the resulting equation is this? And then sketch what the new function looks like, and you can use Desmos to check your graph. Make sure you leave your answer to part A in the comments below, and let us know if you'd like to see more content on combined transformations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.